Hi everyone, welcome back to Sri Sampath Vinayaka Learning channel. Now in this video we will discuss about the Venn diagrams. Okay, Venn diagrams are the pictorial representation of sets and these Venn diagrams are developed by John Venn. Who developed John Venn. Okay, on the honor of his name we named these diagrams as Venn diagrams. And these Venn diagrams are also known as Venn-Euler diagrams also. Okay. Now see we will discuss the different points in these Venn diagrams. We also represent the sets pictorially by the means of diagrams. Those diagrams as rectangle, square, triangle, circle, trapezium, parallelogram, rhombus, kite. Okay, all different kinds of closed figures we may use to represent a set. Okay na? Remember that point Now in Venn diagrams generally we will use a rectangle for representing the universal set. The universal set is usually represented by a rectangular region and its subsets, that means the subsets of that universal set are represented with closed regions. These are the closed regions that is triangle, circle, trapezium, parallelogram, rhombus, all these closed regions inside the rectangular region. In that rectangular region, that is in universal set, we will represent the subsets. Okay, and those subsets are represented by the closed regions called triangle, rectangle. I may use a square, a circle, oval also. Okay, in general we will use a circle or a oval to represent the sets. In general, mostly we will use circle or oval. That means these shapes I will use to represent the sets. Okay, in general. But I may use any closed region to represent a set. Okay, now the elements of the set are written in the closed regions. In these closed regions, I have to write the elements. Understand, And the elements which belongs to the universal set are, let us suppose it is an universal set. Okay, we will write the elements, okay, of the universal set in the rectangular region. Okay, see the elements of the set are written in the closed regions and the elements which belong to the universal set are written in the rectangular region. I hope you understand. We will discuss with some examples. Now see we represent this universal set and these two subsets of that universal set in Venn diagrams. Okay, how to represent that we will discuss here. We already discussed that a universal set is represented in a rectangular region. So I represented that universal set. In that, first I have to represent the two subsets. Okay, while representing these two subsets, first I have to write the common elements in the common region of the two subsets A and B. Here the common elements are 2, 4. Okay na? So firstly I have to fill those elements first in the common region. Then I have to fill the elements which are left in A, 2, the 2 and 4 are filled in the common region. Then the left out elements are 1, 6, 7, 8. Coming to this B, the left out elements are 3, 5, 9. Okay, once check. Is there any element which is left without filling in the universal set or not? Why? Because in the universal set we are having 1 to 10 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 left. So that is why we are going to represent that 10 in the rectangular region. Okay. In this way, we are going to represent the universal set with the subsets in a Venn diagram. I hope you understand. Now, we will discuss how to draw the Venn diagrams for the different set operations. Okay, Nama? See, let us suppose A, B are two sets and mu is the universal set. Then, firstly, we are going to draw the Venn diagram of A union B. A union B means we already discussed that A union B is a set of all the elements which consists of both A and B. That means I have to write all the elements of A and B together. So I have to join or shade both A and B ma. Only A and B we have to shade. Okay, this is our A union B ma. Okay, this shaded region is A union B. A intersection B means no. Okay, now only the common elements of both A and B we have to write. That means only the common region is shaded here. This common shaded region is known as A intersection B. Coming to that, A complement or A dash. A complement means not A. That means except A, rest of all the region of the universal set is shaded ma. Okay. So like this we have to shade except A, the rest of all the region of the universal set is shaded. Okay na ma? So this is said to be A dash. Okay na? Next, A minus B, set difference. A minus B means we know only the elements of A. That means only the A set is shaded. Okay, the common place is not going to be even touched. Okay, now B minus A means only B. Only B is going to be shaded ma. Okay, next, coming to A delta B. We know A delta B means A union B minus A intersection B or A minus B union B minus A. Okay na ma? Just see ma, just join these two figures together, then we will get a figure like this. This is said to be the symmetric difference of A and B. Or if I will subtract this common region from this A union B, then I will get that symmetric difference of A and B ma. Okay na? Now we will discuss the same Venn diagrams if they will give the sets. Let us suppose universal set mu is 1, 2, 3, 4, 5, 6, 7, 8. Okay na? And A is 1, 3, 5, 6. Okay. B is 3, 6, 7, 8. Okay na ma? Now we have to fill the elements in this. The same diagrams you are going to draw, but we have to fill these elements. I already told you that firstly we have to fill the common elements of both A and B. What are the common elements here? Just see ma, 3 and 6. Just we have to write that common element in this 3, 6. Then after we have to write the left out elements in A 1, 5. In B 7, 8. Okay na? Next, what are the elements left without filling in the A and B? Just see from the universal set ma. See 1, 2. So 2 left. 3 filled. 4 left. Okay na? Next 5 filled. 6 filled. 7 filled. And 8 also filled. So like this we have to write the Venn diagram and the elements, corresponding elements in it. Similarly here see ma, 3 and 6 are the common elements. In this shaded region we have to write 3, 6 ma. Okay, and the rest of the elements 1, 5, see ma ikkada, 7, 8, 2, 4. Okay na? Similarly here also in A what are the elements ma? 1, 3, 5, 6. 1, 3, 5, 6. Next 2, 4, 7, 8. We have to write like this. Okay, now coming to this, here what are the elements ma? 1, 5, 3, 6, 7, 8, 2, 4. Similarly 1, 5, 3, 6, 7, 8, 4, 2. Okay na? See ma, 1, 5, 7, 8, 3, 6, 2, 4. Like that we are going to fill the corresponding elements in the Venn diagrams ma. Okay, these Venn diagrams are very important. Now see ma, we will discuss the Venn diagrams of different set operations if A is subset to B. This is our case 1 ma. If A is subset to B means all the elements of A are there in B. So see ma, that A is contained in B. Okay. Now we have to draw the Venn diagrams. First A union B. A union B means we have to write all the elements of A and B together now. As this B is the biggest set, that means all the elements of A are there in B means B is the biggest one. So we will get B only. See, by shading that you can understand easily. In B we are having A. So by shading that we will get B. So A union B is equal to B. It's a very important bit also ma. If A is subset to B, then A union B is equal to B ma. Coming to that A intersection B. We know A intersection B means we have to write all the common elements of both A and B. As that A is there in B, I have to write A as the common elements, and I have to shade that only common place, no? For A and B, the common place is A. So A intersection B is equal to A. Coming to this A minus B, it's empty ma. Why? Because we have to write only the elements which are left in A. As the elements of A are already there in B, there is no element left in A individually. So that's why that is A minus B is equal to empty. This is also very important one ma. If A is subset to B, then A minus B is empty. Now coming to B minus A. So we have to remove that A. Only the elements left in B we have to write. This shaded region shows the only elements which are left in B. That is equivalent to B minus the common elements of both A and B. That is A ma. So see ma, B minus A intersection B. This is also very important one ma. Okay. I hope you understand this. Now see ma, case 2. B is subset to A. B is subset to A means all the elements of B are there in A. This is the Venn diagram for that B subset to A. Now A union B we will see. A union B means all the elements of A and B together we have to shade. So that is why as this A is the biggest set here, A union B is equal to A ma. Okay, now A intersection B is equal to B. Why? Because all the elements of B are already there in A. So for that A and B, the common elements are the elements of B. That's why A intersection B is equal to B. Coming to here, B minus A is empty ma. Why B minus A is empty means already all the elements of B are there in A. There is no element only left in B. Okay na? That's why B minus A is empty. Coming to this, A minus B ma. A minus B means we have to write only the elements which were left in A. So the shaded region here indicates the elements which were left in A. That is also equivalent to A minus A intersection B ma. Okay? I hope you understand these Venn diagrams. Okay? If you like the video, please like and share the video with your friends.